guys, I welcome you in the second part of the shear supported beam simulation, and in this part we are going to do on it this on 3D. So without further ado, we go into the simulation. This is the older simulation that we have did. So double click here. So I go a little fast. No, that's the problem. Sorry, I just opened the wrong thing. Right click here, go to new design modeler. Just the same thing, but I just will give a width of about 1.5 inch to this. So now, as we are here, go here, there, go for sketching, make a rectangle like this, go to units, change the units to inches. Now give the dimensions horizontal, click here, and third click here, click here, and third click here, go vertical, click one, click one, click one, click here, and click here. Good. So change the units to inches, and there are inches, 47 inches, 47 divided by 2 equals to 23.5, 4, and this is 2. Now go to extrude and give a thickness of 1.5 inch, and sketch of this, click here and apply. Now right click here and generate. Now you can see that this is the beam of us. Close it. Just want to see, yes, 1.5 inch of thickness. Now go to model, double click here. So now we are in the simulation. Right click here, insert body sizing, click here and apply. Now right click and update. Now right click here, insert the displacement. Right click, one click here. Now press Control and press this color button. No, not like that. Press color button first of all and rotate it. Now press Control and click here. So now you are selecting two edges. Apply. So you can see that it is showing two faces, and these are the two faces. These are highlighted with the yellow color. Click here and give it 0. Right click here, insert a pressure over the top. Apply. Okay, if you like to do this, then we can do this as well. And the arrow you can see is on the downward side. We can also do it in like the components that we did in the part 1, but I just want to show you a new way of putting the pressure on it. We can both the components and the surface effect have the same thing. They are the same if the direction is same. Just you have to see the direction. So surface effect and normal to means that it is perpendicular to the surface, so it is okay. It is 100% same as we were doing from the components method. So right click here, insert and stress of maximum principle, insert stress 1 mises. Also we have to go and construction geometry, right click here, insert path. Now I would like to show some different paths. Okay, so we are going to make a vertical path. For vertical path, what we have to do is we have to plane the y coordinate, which is -2 and 2. So, and if we want to make it in the middle, then what we have to do, give a 0.75 in the z and other 0.75 in the z. You can make those paths as I've made in the part 1 here also, but in order to show you some different paths, I did this. Okay, you can make that path also, no problem whatsoever. So this is one path. Now what kind of path we should make? Try now I want to try a diagonal path, right? For a diagonal path, what I'm going to do is -23.5 and -2, and now, so diagonal path means that from this corner to this corner, so this particular corner. So for this, first of all 23.5, and it should be 2, not okay, it's 2, but we have to give some dimension in the z as well, so 1.5. So now it is diagonal. I want to show you that it is diagonal. So you can see it is diagonal in all the 3 axes, you can see. So now you can make path like this, you can play with it and make any kind of path, but it is linear. Make sure remember this, that this is linear. Now right click, no, first of all come here, path, and give the path number 1 and insert. Just like the previous video, you can put those post-processor results like factor of safety, maximum principal elastic strain, all of them here as well. Maximum principal strain. Okay, I take that path and give the diagonal one. Now I go here, tools, stress tool. Now it is factor of safety. Stress tool, factor of safety. So it is also taking path. Okay. You can also check that what happens with the variation of paths. So it's up to you that how creative you are. Right click here, solve. So simulation has didn't run. So why we have to turn on the weak spring on. Now right click here and solve. So you can see that simulation has run successfully. You can see all of it. And one thing more I want to show you as we are ending this session. You can see that there's a report by the ANSYS. ANSYS is all calculating all of them and presents you a report like this. Right? For example, if you want to take pictures, like for example, come to the geometry. Now, like for example, if you want to take the picture of this, like this, and this one picture, so then you have to come here and figure. Also come here, not come here, and figure. So now if you go into the report, it is calculating all of your boundary conditions and the post-processor results. So this is the picture in the report and this picture that we have taken. So now if you want to get this report in the PDF format, just press okay, right click also and print. You can also press Ctrl P. Okay, make the Adobe PDF, one copy, print. So Adobe PDF means that it will save into the Adobe PDF format. So I will name this Shear supported part 2. Same mesh dependency test can also be performed on this simulation as well. Now I want to show you the report. So reports comes out automatically. There are 20 pages in this report, and with Acrobat DC I can also convert it into the Word and take the necessary data I need to display to my team. So with the report I want to end this simulation. Just want to show you that we can also do the parametric study or the measure dependence test with multiple parameters as well, like give this P. Now maximum principal stress, okay, give maximum P, and also like strain maximum P. Now you cut off, and there are parametric sets as well. Click here, so you get parametric study of this as well. Then what you can do is Control Shift down arrow key, down, down, and one on the right, and right click here, update all selected design points. So this will update all these. Also, you would have noticed that the pressure was approximately same. It was not varying with the width. So with these results, I want to end my video. Thanks for watching.